Hello, everybody. Mr. Hennon here, and I am with the Henstitute on kinematics in 2 dimensions, projectile motion. We are going to look at launched at an angle. This time we're going to find horizontal displacement. So we're going to go back to the same problem. This place kicker is kicking a football at an angle of 40 degrees, 22 meters per second. Assuming there's no air resistance, the ball is landing at the same height that it was launched. We're going to calculate the range or horizontal displacement of the football. So the first thing we got to do, same thing we've been doing, we've got to change this from 22 meters per second at an angle, this 40-degree angle, into a VIY and a VX. So that's just going to be our 22 times the sine of 40 degrees and the 22 times the cosine of 40 degrees. So we've done this already. Handy dandy calculator here. Make sure you are in degree mode. And 22 times the sine of 40 gives me my 14.1413. And my 22 times the cosine of 40 gives me my 16.853. So let's write those down. 14.1413 meters per second and 16.853 meters per second. If I'm going to solve this, the first thing I have to do is actually find the time of flight. We did this before, but I just want to kind of go through it again really quick. I'm actually going to do it in a slightly different way this time. I'm going to use the fact that the y is 0. Our gravity is 9.8 meters per second squared. I'm not going to worry about this. I know that this is negative 14.1413 meters per second, and this is the positive 14.1413 meters per second. But I'm going to find time using those. So to kind of throw this out and find that time of flight, I'm going to use a different equation. I'm going to use the fact that y, whoops, I didn't want to go back. Let's go cover that again. I'm going to use the fact that y is equal to VIYT minus my 1/2 GT squared. Now we've done this where VIY is 0, but it's not 0 anymore. It's this number, but y is 0. So here's the cool part. If y is 0, then really, since this is 0, these two pieces have to equal each other because I can bring this over to the other side, and I'm basically saying they equal each other. So VIYT has to equal 1/2 GT squared. Well, guess what? One of these t's can go away, and we got VIY equals 1/2 GT. So to solve for t, watch this. It's going to multiply by 2. So I have 2 times my VIY over g. That's basically the same thing I've been doing with the other equation. So when I do that, I take 2 times my VIY, my 14.1413, divide that by 9.8, get 2.8859, blah, 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 or about 2.89 seconds. So now I have the time. I should be able to find out how far it goes. So I'm going to switch, and to find this horizontal displacement, in other words, the football goes from here through the air and lands somewhere over here. How far horizontally is it going to travel? That's what they sometimes refer to as the range, but really that's a fancy way of saying x. AX is 0, so I don't have to worry about that. VFX and VIX are the same, so we just call them VX. We already have done this. This is our 16. Hey, look, we get to use this number now. 853 meters per second. We just figured out the time is 2.89 seconds. To find our range, our x, we just have to take Vx, the horizontal velocity, and multiply by that time. So to do that, I just have to take my 16.853. I'm going to multiply it by the time, chunk that out, and I get 48.637, so about 48.6 meters. And ta-da, I have a way of finding the horizontal displacement of a particle. But notice that all these things kind of build on itself. I have to find time, use that to find horizontal displacement. So I'm using some of those same kind of concepts. So I'm going to leave you with this one. Let's say a baseball is hit and it's going to hit at a 70-degree angle. So it's really high of an angle. It's hit at 35 meters per second. That's somewhere around 75 miles per hour, assuming there's no air resistance, and the baseball is hit and lands at the same height. In other words, they're going to catch it at basically the same height that it was hit from. How far horizontally would the baseball travel? So this is going to be your question that I want you to try to answer in the Google form. Hope you enjoyed this edition of the Henstitute and look forward to one more coming up.